Hello, my name is Christian Martinez, and this is my performance task final product for Education 407. Today we'll be focusing on the standards of earth science and geometry modeling. The first standard is apply concept of density based on the area and the volume in modeling situation. And then the add-on standard that we're going to be doing as well is going to be students know the appearance, general composition, relative position and size, and the motion of objects in the solar system. So first I'm going to show you a quick little video of our planets going from smallest to biggest in actual size. Those were all of our planets including the sun, and for a better comparison of all our planets, I pulled up this picture that shows in actual size how the planets look like compared to each other. For this assignment, one of our main ideas was to find objects that are the same to scale as our actual planets. So what I had to do first for this assignment is I had to find a fact sheet, which is shown right there on the screen, of our planet's diameter. After that, I picked one particular planet, for example, Uranus. The diameter is 51,118 kilometers, and I wanted to compare it to a basketball. And a basketball is 9.55 inches in diameter. So what I ended up doing is I ended up converting the kilometers into inches. And then from there, I ended up dividing both. So once I divided 2 million, uh, 2,012,519,682 inches into the 9.55-inch basketball, I ended up getting 210,735,045. So that's the ratio that I did from now on. So that's the ratio 201,735,045 to 1. So for every 1 inch that we, or for every one product that we have, that's how much we'd have to times it to get the exact scale. So I basically did that for every single planet, and then after I converted every planet's diameter to inches, I divided it by the 210,735,045, and I ended up with inches of each diameter. What I did from there is I started to look for specifically these inches to see what they compare to the most. Venus would be like a pool ball. Earth, because it's similar diameter, it'd be the pool ball too. It's a marble, a bouncing ball, yoga balls, and then once I got all my products, once I got the math done, then I began to look, okay, what objects would fit best, and this is what I came up with. As you see here, I did Pluto as a raisin, Mercury as Mercury as a marble, Mars as a cotton ball, Venus as a lemon, Earth as a pool ball, Neptune would be a soccer ball, Uranus that's where I started with, and that would be a basketball right here, and then Jupiter and Saturn would also both be yoga balls. Just I think one would be a slightly bigger than the other. So then the only thing that would be left, along with all the planets that we have here, would be the sun. So the sun, compared to all of our planets, it's pretty massive. Here's a video that show a comparison of how big the sun is compared to all of our smaller planets. So then once I had that, I had to figure out what's big enough. So there it is. This is the largest baseball in the world, and has a diameter of I think 29. I think it's 29 feet. No, a diameter of 29 inches, I believe. After that, the next assignment we had to do is we had to, if we were to line up the planets just like this, we'd have to figure out the distances between them in feet and then post it on our map. So the math for this assignment that I did is I found a fact sheet once again of all the planets' distances between each other. If you see there, it shows all of them, but it doesn't show the specific ones we want. So I had to go through that, and then I had to specifically just pull out the ones we need, and I made a little chart out of it. And because we're working on inches as our ratio, all of our all of the ones that they showed here were in kilometers. So once again, I had to convert them all into inches. After that, I went ahead and you see right on the bottom. Once I converted it to inches because it was such a large number, I divided it by 12 again to turn it into feet. And as you see here, the sun to Mercury is 714 feet away according to our ratio. And then so on and then so on. And at the end, the final product I got was, if we were to have sun where our classroom is, which is right here in the Barclay building, I believe Mercury would be basically, I guess, where the glass building is at. And then Venus will already be out of the school, and then Earth would be in the street. And if you continue to see the distances, Sun compared to the Moon, compared to Pluto, would basically be miles away over in, I believe it is Azusa. So to show of how big our solar system is, imagine Sun. Imagine we go back to this image. Sun is right here, and that's the size of a yoga ball, and Earth would be about, I want to say, 4 blocks away, just being the size of a pool ball. That was my presentation. I did the map like I was supposed to, and I also did objects to scale, and I hope you enjoyed my video.